This is an intimidating looking problem because we have these pesky 2's in front of the x squared and y squared terms. Let's start by trying this the old-fashioned way for all the purists out there, and then we'll see if Desmos can save us any time. First off, we'll divide by 2 to make it easier for us to complete the square. Then once we have that, we'll group all of our x terms and our y terms on the left side. And now this is the crucial step. We need to divide the coefficient of the x term in half, square it, and add it to the parentheses to complete the square. And of course, we can't go adding numbers willy-nilly where we want to without balancing out the change on the other side. So the right side also gets a 9/4. Similarly for the y's, the coefficient on the y term is 1, so if we cut that in half and square it, we need to add a 1/4 into the parentheses. Then condensing everything into standard form leaves us with x minus 3/2 squared plus y plus 1/2 squared. And finally, on the right, that simplifies to 25, which is 5 squared, so the radius is 5. Now, let's compare that experience to using Desmos. The high point is 4.5, and the low point is negative 5.5, which makes the diameter 10, so the radius is 5. In the xy plane, the graph of the given equation is a circle. Which point xy lies on the circle? Well, let's just plug in the answers and see which one works. A, 6 squared plus 11 squared is not 100, so A's out. B, 6 squared plus 8 squared is 100, so it's B. Now, we could obviously use Desmos as well, simply by plugging in the equation of the circle and then plugging in the points and seeing which point lies on the circle. But all of that typing takes about 25 seconds, whereas it only took me 10 seconds to do in my head. So there's a lesson here. Just because you can use the calculator doesn't mean you should. Which of the following is an equation of a circle in the xy plane with center 0, 4 and a radius with endpoints 4/3, 5? We know based on the equation of the circle that the answer must be either A or C because we need a y minus 4 term. And then the only thing left is to find the r. We can do that using the distance formula, and that works out to 5/3, which means r squared is equal to 25/9. And so the answer is A. Now, if we'd used Desmos, we would just plug in the point and then start checking answers. So does A work? Sure does. The equation x squared plus y minus 1 squared is equal to 49 represents circle A. Circle B is obtained by shifting circle A down 2 units in the xy plane. Which of the following equations represents circle B? So we know that the old center is at 0, 1, and the new center needs to be at 0, -1, and so our equation should be x squared plus y plus 1 squared is equal to 49, which is D. You could use Desmos by plugging in the original equation and then plugging in answer choices until you find one that's translated 2 units downward from the original, but that's a little tedious. The graph in the xy plane of the equation above is a circle. If the circle is translated downward a units such that the circle is tangent to the x-axis, the equation becomes x minus 6 squared plus y minus 3 plus a squared is equal to 25. What is the value of a? We know that the radius of the original circle is 5 and the old center is 6, 3. And so we need the new center to be 5 units below the x-axis, so it must be at 6, -5. That makes the new equation x minus 6 squared plus y plus 5 squared is equal to 25. And so in order to get y plus 5 squared, we need a to equal 8. If we use Desmos, we would type in the original equation of the circle and then add an a term with a slider, and then just adjust the slider until the x-axis lies tangent to the top of the circle. Now, a word of caution on this, make sure that the gray dot at the top of the circle truly is on the x-axis, and you can verify that by hovering over it. The graph of the given equation is a circle in the xy plane, and the point AB lies on the circle. Which of the following is the possible value of A? The center of the circle must be -4, 19, and the radius is 11, which means that A must be between -15 and 7, and answer choice B gives us the only option in that range. We could use Desmos to help us visualize the range of possible A values. To do that, we'd plug in the equation of the circle and then plug in each possible A value, and as we can see, -14 is the only A value that overlaps with the circle, so it must be B. A circle in the xy plane has equation x plus 3 squared plus y minus 1 squared is equal to 25. Which which of the following points does not lie in the interior of the circle? A good start is always to identify the center and radius of the circle given. So here we have -3, 1, and r is equal to 5. Now, we can use the distance formula to figure out which of the answer choices is more than 5 units from -3, 1. And so with A, we have root 16 plus 4, which is root 20, so that's less than 5. B is the center, so that's out. C is square root of 9 plus 1 away from the center, which is also less than root 5. And then we're left with D. The distance between -3 and 3 is 6 in the x direction alone, so that has to be it. If we use the calculator, this is real straightforward. Toss everything in Desmos and pick the one that's not like the other. If you found this video helpful, be sure to subscribe and check out my next video on arcs of circles.